At the top of the next page, we just have a summary of all of that arrow notation that we were talking about on the previous page. I'll let you just study over your notes, and if you have a question, we can talk about those in class. So what about the domain? Now, we've talked about domain many times so far this semester. Remember, we had those two conditions. The first question is there a variable in the denominator? The second question is there a variable under a square root? We do have a variable in the denominator, but we don't have a square root. So what do we do when we have a variable in the denominator? We know that the whole denominator cannot be 0. So we subtract 2 from both sides, which tells us x cannot be negative 2. So the domain is everything except negative 2. So the whole number line, but not negative 2. This is our domain. Well, remember on the previous page, let me go back to that real quick. On the previous page, we were saying that as x gets smaller, y goes to 0, etc. What I want you to notice is there are these lines that are kind of blocking your function. See how your function is blocked by these lines? So we have, it's kind of constricted to this space and constricted to this space. Same thing is happening over here. We have a line right here and another one here that is blocking our graph. Those lines that kind of block or they curve your graph, those are called asymptotes. We have different types. We have vertical, horizontal, and oblique asymptotes. So let's talk about vertical asymptotes first. A vertical asymptote will happen everywhere the denominator is equal to 0. So if you're looking at that problem, actually we're going to look at that one on the next page. So right here we have a vertical asymptote at x equals 0. Remember, this function is 1 over x, and remember x cannot be 0, right? So we have a vertical asymptote at wherever the denominator is 0. That's pretty much what all of this is telling you right here. So that problem we were just talking about, this is the same one. If this function has a vertical asymptote listed, well, the denominator can't be 0. That's where your vertical asymptote is going to occur. So you have a vertical asymptote at x plus 2 equals 0. You have a vertical asymptote at x equals negative 2. Let's see if we can sketch the graph of this really fast. So we go to y equals, we have 1 divided by x plus 2 plus 3. And, oh no, yeah, that's right. Graph. Do you see that at x equals negative 2, there's this invisible line right here? That is representative of your vertical asymptote. Now, sometimes you have what's called a removable discontinuity. That just means you're going to make a hole in the graph. Removable discontinuity means a hole in the graph. I'm going to let you read all of this paragraph, but I want to talk to you about what it really means. Identify the domain, any removable discontinuities or holes in the graph, and all vertical asymptotes of this function. Well, to do that, what we need to do is factor it. This is equal to x minus 2 over x plus 2x minus 2. Because this is difference of squares, it will factor into this. If we're talking about the domain, remember the denominator can't be 0. So x plus 2 can't be 0, and x minus 2 cannot be 0. Subtract 2. X cannot be negative 2. Add 2. X cannot be 2. So your domain would be everything except these two values. Negative infinity to negative 2. Negative 2 to 2. And 2 to infinity. This is your domain. Well, if you'll notice, after we find the domain, we look at discontinuities. If you reduce this, these two go away, and you end up with 1 over x plus 2, right? That does not affect your domain. You get your domain from the original function. But what you have left over helps you discover where the discontinuities are. I'm just going to write holes because it's faster. We have a hole in the graph at the place where we reduced it. So x minus 2 is where we have a hole. So we have a hole at x equals 2. Well, what if you want to find out what that point actually is? Plug this in the reduced form of your function. So we're going to have a hole in the graph at the point 2, 1/4. We have a removable discontinuity there. So now we have to talk about the vertical asymptotes. Your vertical asymptotes are in the reduced form of your function, whatever makes the denominator 0. So you have a vertical asymptote at -2. And don't forget this is an equation because it's a line. You have a vertical asymptote at x equals -2. Let's see if we can get a graph of this one. So we have 1 divided by x plus 2. So we have a vertical asymptote at -2 again. Whenever you have a hole in your graph, you can't see it in the picture. Even if you typed in this function, you still could not see it on this graph. So you will need to be able to do this one without using your graphing calculator. It won't tell it to you.